Alright, good day. You're welcome to Master Lectures. And in today's video lesson, we're going to be learning about chemical bonds. Alright, or you say chemical bonding. Now, this is one essential area for those of you that are preparing to write this 2026 JAM or WAEC examination. Okay, this is a very important topic that you must know for those of you writing JAM or WAEC 2026. So, my name is Samistro. Alright, so let's go into chemical bonds. Now, what are chemical bonds? Let's go. Chemical bonds are attractive forces that joins chemical species, be it atoms, molecules, or ions, together. So, chemical bonds are responsible for holding or joining species, whether be it atoms, molecules, or ions. Chemical bonds are responsible for joining them together. For example, if you look at chlorine molecule, chlorine is a diatomic molecule. It is written as Cl2. That means you have two atoms of chlorine here, which is Cl and Cl. So what type of bond holds one chlorine atom to another? Okay, so this chlorine is connected to this chlorine by chemical bonds, right? So what is here is your chemical bond. But then what type of bond? We'll learn that as we proceed in the lesson. Are we together? Alright, now let's go. So that is it for chemical bonds. That's the definition of chemical bond. Now, most of the bonds results from the tendency of other atoms to acquire the stability of noble or rare gases. Now, why do elements enter into chemical combination with atoms of themselves or atoms of other elements? Why is it that sodium love to enter into chemical combination with chlorine to form sodium chloride? Why? Now, the reason is because of stability. That is just the issue of stability. So, chemical bond results as a condition whereby two atoms that are not stable, right, wants to be stable. And in order for them to be stable, they need to come together to form chemical bond. Now, the stability of all atoms, of other atoms, of elements, the stability of elements is the ability for them to have either the duplet structure of stability or the octet structure of stability for the noble gases. So look at it now. It says most of the bonds result from the tendency of other atoms to acquire the stability of noble or rare gases. So most of the bonds is as a result of other atoms trying to acquire what? The stability of the noble gases. Now, what is the stability of the noble gases? Now, what? This stability is due to their duplet or octet structure of stability. So, all atoms are either trying to have the duplet structure of stability. In the case of helium, this helium, duplet structure of stability. Alright? Now, if you look at this helium, now if you look at hydrogen, hydrogen is just having one electron. So this hydrogen. So what hydrogen wants is to achieve the the duplet structure of helium. Duplet means two. Alright, that is what hydrogen wants to achieve. Then sodium. Sodium is 11. That's 11 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sodium just have one outside. Alright, so sodium needs 7 in order for it to get what? 8, the octet structure of stability. So it needs what? 7. Alright, so that is what sodium needs. So it's to achieve the octet structure of stability. So this is it for all other atoms. Alright, so that is what the essence of chemical bonds is all about. Now, having gone through this, when we are talking about chemical bonds can be broadly divided. Chemical bonds can be broadly divided into mainly two. We have intramolecular bond, and then we have the intermolecular bond. Now, what is the intramolecular bond? The intramolecular bond consists of three bonds, three chemical bonds. First, we have the electrovalent bond, and then we have the covalent And lastly, we have what? The metallic. Alright, that's the ECN. And just a code ECN. Electrovalent, covalent, and then metallic. Alright, now what are intramolecular bonds? Now please take note, this way I will advise you to write. Now, intramolecular bond, alright, intramolecular bond exists within, okay, it exists within what? Molecules, and it is responsible whether you say within molecules or atoms, whichever you want to use, or atoms, right? And it is responsible for the, alright, or you say it is responsible, or you say determines the chemical properties. Alright, so now intramolecular bond exists within molecules and it is responsible, or you say it determines what? The chemical properties. Alright, now there was a question, SSC, a WAEC question in 2017, question number 1. It was a simple question. They said, which of the following determines, which of the following species determines the chemical properties of atoms or elements? You have it as we have neutrons. B, we have electron. C, we have proton. And then in option D, there was one other option like that. Let's just say positron. Now this was a WAEC question in 2017. They said which of the following determines the chemical properties, or which of the following, yes, determines the chemical properties of atoms. Now the answer is electron. Do you know why? Now look at what I was doing here. Remember, I told you elements enter into chemical combination because of their number of electrons. So they want to either have the octet structure stability or the duplet. So hydrogen has 1 electron, alright? It needs extra 1 to resemble helium. Sodium has 1 outside, it needs extra 7 to resemble neon or argon. Alright, so that you just have 8 outside. So electrons, the relationship between one atom to the other in order to form chemical bond is based on electrons. I repeat, the relationship or the connection of one atom to another to form chemical bond is based on what? The electron. Alright, so the answer is actually what? The electron. Now this is a basic fact. Alright, this is a basic fact you need to know. This is a basic fact. Now take note that in organic compounds, functional group determines the chemical properties. So please take note, if you are asked for just normal O-level chemistry, alright, probably you'll say what determines the chemical properties of atoms. Normal inorganic chemistry, what determines the chemical properties of atoms? What will you say? Electron. But when it is now be stated, what determines the chemical properties of organic compounds or inorganic compounds? What determines their chemical properties? So the answer becomes what? Functional group. So please take notes. Alright, now let us come back. Now let's begin with electrovalent bonding. Okay, so now let us discuss electrovalent bonding. Okay, so now what is electrovalent bonding? Now electrovalent bond electrovalent bond is also called ionic bond. Please take note of this, especially for those of you writing WAEC or JAM. Please take note of this. Ionic bond. Electrovalent bond is also called what? Ionic bond. Now, electrovalent bond is formed between what? A metal. This type of bond exists between a metal and a non-metal. Okay, the bond that is formed between a metal and a non-metal, what will you say it is? It is what? Electrovalent bond, also called ionic bond. The bond formed between a metal and a non-metal is called electrovalent bond, aka ionic bond. Alright, aka means also known as. Alright, so electrovalent bond is also known as ionic bond, and it is a bond formed between a metal and a non-metal. Now, the mechanism of electrovalent bond is that it involves the transfer of electrons. Alright, electrovalent bond involves what? Involves the transfer of electrons or electron, depends. Right, involves the transfer of electron, or say electrons, from a metal to a non-metal. So the bond formed by the transfer of electron from a metal to a non-metal, what do you say? It is what? Electrovalent bond. And the electrovalent bond is also called ionic bond. So that is it for electrovalent bond. So examples of compounds where you have electrovalent bond, metals and non-metals. So e.g., you have sodium chloride, NaCl. You also have KCl. Basically, any compound where you see that one of the atoms that makes up or one of the elements that makes up the compound is a metal, while the other element is a non-metal. So in that case, electrovalent bond, ionic bond kicks in. Now, what is covalent bond? Covalent bond, this type of bond, right? This type of intramolecular bond results from the sharing, right? This bond occurs when electrons are being shared. Okay? This bond occurs when electrons are being what? Shared. Alright? So the sharing of electrons is what leads to the formation of what? Covalent bond. The sharing of electron leads to the formation of covalent bond. Now, watch this. A covalent bond can either be ordinary covalent bond, or we say it is what? Coordinate covalent bond. Now, coordinate covalent bond, please take note, coordinate covalent bond is called dative bond. Alright, coordinate covalent bond is called what? Dative bond. Please take note of that. Now, remember, covalent bond results from what? Sharing of electrons. Now, how does ordinary covalent bond happens? Now, listen, ordinary covalent bond happens when the electron that is being shared. Ordinary covalent bond happens when the electron that is being shared is donated equally by the two participating atoms. So if you have, let's say, atom of chlorine wants to combine with another atom of chlorine. Now, if this supply one electron and this also supply one electron, that both of them now later share, that is what we call ordinary covalent bonding. So in ordinary covalent bonding, the electrons that are being shared are donated by the participating atoms. It's just like for we Nigerians, alright, you say, okay, I have rice, but I need beans. And you have a friend who says, I need rice, I have beans. So what happens? You have rice, you're looking for beans. Your friend has beans, looking for rice. So what do you now share? You now divide the only two. You say, okay, take my rice. You also divide your beans. So take half of my rice, give me half of your beans. So that is equal sharing. So that is what leads to what? Ordinary covalent bond. Now, ordinary covalent bond is found in most covalent compounds. Now, Covalent compounds or covalent bonding is a type of bond that is present in the combination of two non-metals. So when two non-metals come together, the chemical bond that is being formed is what? Covalent bonding. So we have, for example, e.g., hydrogen combined with oxygen to form water. Here you have what? The ordinary covalent bond, because the electron is shared equally between oxygen and hydrogen. So hydrogen donated the same amount as oxygen and they share it together. So that's equal sharing. So you have water. So hydrogen is a non-metal, oxygen is a non-metal. So you also have chlorine molecule. We have chlorine molecule, Cl2. Okay, we have hydrogen chloride gas, HCl. Now most compounds that have, that are just combination of non-metal and non-metal, that is, we have covalent bond. So for coordinates, that is ordinary covalent bond for that one. Now for coordinate covalent bond, aka dative bond, this one results when the electron that is being shared is donated by one of the participating atoms. This is also known as a greedy covalent bond. I call it a greedy covalent bond because it's very greedy, right? Now the electron needed to be shared is only donated by one of the participating atom. So it's just like, I have rice, I'm looking for beans. You have beans, you're looking for rice, but I'll just come and just use my masculinity and my authority to seize your beans from you. So I add it to my own. So that is a greedy kind of behavior. So that is the way it is for coordinate covalent bond. And examples of compounds with coordinate covalent bonding, examples of compounds with coordinate covalent bonding, we have hydrozonium ion, H3O+, we have ammonium ion, NH4+. We also have complex salts like copper 2 tetraamine. Copper 2 tetraamine. All right. So please take note of this. Take note of this. Now, bear in mind that complex salts have dative bond. All right. Complex salts have what? Dative bond. Okay. So lastly, the last type of bond we are going to look at is metallic bonding. Now, what is metallic bonding? Metallic bonding, it is a bond that exists within what? Atoms of a metal. All right. The bond is present. This bond is present. It is present within what? Within atoms of metals. All right. So metallic bond is present within what? Atoms of metals. So within atoms of metals, we have what? Metallic bond. So if you are given a question and you are asked, what type of bond exists or is found in aluminium foil? What type of bond is present in aluminium foil? Or you might see this way: what bonds help to hold atoms of aluminium in a aluminium foil? Now, aluminium is a metal. What type of bond that holds the atoms of aluminium is metallic bond. All right, metallic bond. Now, I also want you to blast on something else. Now, this one is another important fact. Now, listen. The higher the valency of the metal or of a metal, the higher the valency of a metal, the stronger the metallic bond. Are you with me? So the higher the valency of a metal, the stronger the metallic bond. Now, sodium atom has a valency of +1, calcium has a valency of +2, aluminium has a valency of +3. Now, among these three, which one of them will have the strongest metallic bond around these atoms? The answer becomes what? Aluminium. Aluminium is going to have the strongest bond, the strongest metallic bond between these atoms, because the valency of aluminium is high. It's +3. So please take note, the higher the valency of a metal, the stronger the what? Metallic bond. Now take note again, please write this down. Metallic bond is responsible for the metallic properties of metals. So the properties of metals is determined by what? The metallic bond. Alright, so the metallic bond determines what? The metallic properties of metals. Are we together? So that is it for everything. Please, I want you to watch this video, go over it again and again, and you get the concept. So thank you very much for watching. God bless you, and I'll see you in the next video. Peace.